Okay, class, we're coming back on section 10.6, factoring quadratics that have a leading coefficient not equal to 1. And we're going to pick up with example 3. And in this example, we have 6x squared plus 2x minus 4. Okay. All right, we're gonna continue using the box method, but this is one of these examples where I can see that I do have a common factor in all three of these terms. So you want to take that out and do the box on what's left over. So what is the greatest common factor between all three of these? It looks like it's a 2. So I'm going to basically factor a 2 out of each of these terms. So if I factor a 2 out of 6x squared, what am I left with? I'm left with 3x squared. If I take a 2 out of the 2x, what am I left with? Well, I'm left with an x. And if I take a 2 out of negative 4, I'm going to be left with negative 2. Now what you're going to do to factor this, you're going to factor that part without, with this 2 out, taken out. Now, you're going to leave the 2 just sort of floating out there because, it is part of the original a quadratic expression that you're factoring, but to do the box now, you just do it on this middle part. Okay, so I'll show you what happens if you don't do it. Okay, all right. So we're going to put 3x squared here. We're going to put a negative 2 here. I'm going to multiply my first and last terms. That gives me a negative 6. And I have to have that combine into a positive 1 for my x terms, right? So that tells me that the larger factor, the larger absolute value is going to be positive, and then the smaller one's going to be negative because it's going to turn out to be a positive. If I did 1 and 6, well, that's positive 5. That's not going to work. If I did negative 2 and positive 3, there you go. That's my combination. That's going to give me a positive 1, right? And these are my x factors. So I'm going to put a negative 2x here. I'm going to do a negative 3x here. Okay, now remember, if I'm touching a negative box, which this term and this term will be, then my term's going to be negative. All right, so what's the GCF between negative 2x and negative 2? Well, it's 2, and then since this is touching a negative, that's going to be negative 2. All right, how about between 3x squared and negative 3x? Well, that's going to be a 3x, right? Okay, going sideways between 3x squared and negative 2x. Well, I have just an x in common. And then right here between negative 3x and negative 2. Well, I just have 1. And again, since I'm touching a box of a negative thing, this is going to be negative. So this is going to factor. My 2 is still here. It's going to factor into this and this. So I'm going to get 3x minus 2 times x minus 1. Okay? And there you go. If I FOIL all this through and then multiply the 2 to everything, I'm going to end up back where I came from, right? Because I'm going to end up with 2. Let's say I FOIL this. I'm going to get 3x squared minus 3x. Uh-oh, wait a minute. Did I get something wrong here? Minus 3x, all right? I got something wrong. Minus 2x plus 2. I've got something wrong on my signs. What did I do? Did I write something down wrong? Okay. Let's see if I can figure this out. Oh, okay, I know. I need to put a plus right here. That's what I needed to do. Yeah, I said negative 2 and 3, and then I proceeded to put a negative there. That should be a plus. Yes, that needs to be a plus. Okay. All right, maybe you caught that before I did. But so what's that going to do? Okay, so that's 3x squared. Then that's going to be plus 3x. That's better. Minus 2x. And then this is going to be minus right here. Okay, there. Now it works out. All right, 3x squared. That's plus x minus 2. And then the last step is, of course, you can redistribute that 2 right through here again. And you would get your original equation back. Now, let's say you didn't notice that everything was divisible by 2 and you just went right directly to the box. Okay, well, this is what's going to happen. Here, let me see if I need to erase a little bit so you can, okay. All right, so let's say you just jumped right into the box and you put everything in. Okay, and you didn't factor out that common factor. You put 6x squared here, and then you put a negative 4 here, and then you're looking for factors of negative 24 that combined into 2. So negative 24 that combine into positive 2. So positive larger factor there, and you said, okay, well, that's going to be negative 4 and 6. Okay, that combines into positive 2, right? So you got a 6x here, and you have a negative 4x here. All right, so if you go up, up, over, over, let's see what you end up with. Well, you'd end up with a 2 here, right? You'd end up with a 2x over here. You'd end up with a 6x here, and you'd end up with a negative 4 here. And so what ends up happening, it sort of like doubles everything. I don't know, just the box method just doesn't work if you don't factor out this. So you end up with 12x squared. You're going to get plus 12x minus 6x, and you're going to get minus 8. And so this becomes 12x squared plus 6x. Oops, my pen has decided it's not going to work anymore. 6x. Okay, and then minus 8. So it's just like way off. I mean, it's just, it just turns out to be just kind of crazy. Did I do this right? Let me see. That's 12. Yeah, that's 12x. Oh, that's minus 8x. Okay, this is what's wrong. Okay, minus 8x here. Okay, so that's going to be plus 4x and then minus 8. Okay, so it ends up being like double this. And so that's why it doesn't work, and that's why you have to do the box method only on quadratics that have, that are where the terms are mutually prime. In other words, they don't have any common factors at all. All right, so how about you guys do the checkpoint for 4 through 9, and I will provide that as a paper check for you. And then as far as example 4 goes, okay, and then come back, okay, and then we will do the rest of this section, and then we'll be done.